Okay, see Lindelof videos. This video is actually by request, so let's do this really quickly. This is solving multi-step equations, and there are some basic types that you're most likely to see, so I'm going to try to go through about 5 examples of different types. Here's the first one where we have our variable r up here is in the numerator of a fraction. So we have to figure out how to get this, how to separate this r from this 10 down here. But before we do, we just do the basic algebra that we're used to, which is that we're going to move everything away from the variable, starting with addition and subtraction. So I'm going to subtract 4 from both sides. I get r over 10 is equal to 1. I put this 1 up here like this for a reason, and the reason I'm going to do it is I'm going to rationalize this 1. So 1 is the same as 1 over 1, isn't it? Because what I'm going to use is something called the means extremes theorem, which just frankly means to cross multiply. And I just want to show you why it's okay to just multiply across. Look at this. I think that 1/2 is the same as, I don't know, 5/10. So you can try this with fractions yourself. Set up a fraction you think is equivalent to another fraction and check its proportionality. So if I cross multiply, 10 times 1 is 10. Cross multiply the other way, 2 times 5 is also 10, and 10 equals 10. It doesn't matter what these numbers are as long as they're equal. As long as they're equal to one another. So that's what I'm going to do here. So I'm going to cross multiply. I'm going to do 1 times r, which of course is just r, and then I'm going to do 10 times 1, which of course is 10. So our answer here is 10. So okay, so that's type 1. Let's go quickly to type 2. Second type of multi-step equation that you see often is one that makes you use the distributive property. So what I've seen a lot of times, you'll have a student who will try to actually subtract this -3 out here. So we're not going to subtract this -3, but I am going to keep in mind that this is a -3. Right? It's a -3. And then I'm going to distribute this completely. So I'm going to distribute -3 times x, and then I'm going to come back to this 3, and I'm going to distribute again to this other term. So I'm going to go ahead and do that. -3 times x is -3x. -3 times +2 is -6, right? And I'm going to bring all the rest of this stuff down. This equal sign is this one, and this 6 is this one. Now I'm just going to keep working on my math. This equation looks a lot more basic now. So of course we're going to add 6 to both sides, right? Because we have a -6. So the opposite of -6 is +6. 6 plus 6, I'm sorry, 6 plus 6 is 12, and 12 equals -3x. Lastly, we're going to divide, right? So we're going to divide both sides by -3. And we get 12 divided by -3, which is -4, equals x. And of course, reflexively, I don't know what your teacher or professor asked you to do, but reflexively, we can just flip that over and say that x is equal to -4. Both ways are equally true. You just have to ask your professor or your teacher how he or she wants it. So there we go. All right. So third type is when we have variables on both sides. So we have variables on both sides. So what we need to do is just make a decision. Which side do we want our variables on? We're going to move all of our variables to one side and our constant values to the opposite side. So what I usually do with this is I just look and see where most of my variables are. And there are 12 x's here and there are 8 here. So I'm going to go ahead and move all my x's to the left. So I'm going to do that by subtracting 8 x's here and 8 x's here. I'm going to do 12 x's minus 8 x's, which I believe is 4x, minus 4, right? 8x here minus 8x is 0, leaving 4 here. Yeah? So I'm going to do the obvious. I'm going to add 4 to both sides. 4 here, add 4 here. We get 4x is equal to 8. Divide both sides by 4. Divide both sides by 4. And get x is equal to 2. By the way, I've not done these problems in advance, so hopefully I'm getting everything right. I think that I am, but I don't usually do the problems in advance, so there we go. Next problem I'm going to do is this one. X plus 9 divided by 2 equals 3. And I want to be clear about why this is a different type of problem. We had a problem earlier. I think it was r over 2 plus 10 or something weird like that. I just want to be clear that this x and this +9 are both in the numerator. So we can't take them apart because we have to use order of operations, right? PEMDAS. So this x and this 9 are stuck up here through division. So this is not the same as this. However, I guess that's the bad news. The good news is that we can use our cross multiplication strategy. And when I'm going to multiply completely, I'm going to distribute complete, so I'm going to multiply the 1 times the x, and I'm going to go back and multiply the 1 times the positive 9. So 1 times x is x, 1 times 9 is 9, and then we're going to cross multiply back, and 2 times 3 is 6, right? So I am going to subtract 9 from both sides, yeah, subtract 9, and I get x is equal to negative 3, I believe. All right, so those are just the basic thing, some of the basic types of two-step equations that you're going to see. Hopefully this video is helpful. And what I would do is I would look for other problems like this and just work through them and get used to it. So when you see a problem, you say, "Oh my gosh, it's that type of problem." All right. Hey, thanks for watching. If you have questions or comments, please let me know. And if you haven't already subscribed, please. Thanks. Appreciate it.